I'm Gupta and I'm 12 years old. I'm the founder of 10xcoderkids.com, and if you like this video, please don't forget to smash the like button and share this video with as many people as you can. And if you haven't subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are going to learn about C++ arrays. So today we are going to know about arrays in C++, and this is going to be a very interesting video. I guarantee that to you. So without any delay, let's get started. Damn! Okay, so what are arrays? First of all, arrays are used to store multiple values in a single variable instead of declaring separate variables for each value, right? So if you have a lot of values, instead of declaring one new variable for each value, you can have an array where you can store all your values. To declare an array, define the variable type. So what type of values you want in your array. So if I want string values, I'll say string, and and then you have to say specify the name of the array. So you have to give the name of the array. So we'll just say cars, right, followed by square brackets. So you have to give square brackets, and in square brackets you have to specify the number of elements it should store, the array should store. So for example, we want 4 elements, so we'll say the array should store 4 elements, and after that we have to just give a semicolon to end the statement, and after that, after this statement, we can now add elements to our array. So this is an empty array, right now it is an empty array. So to insert values, we can use an array literal. Place the values in a comma separated list inside curly braces. So what we'll give, to give values over here, we'll just say curly braces, and then we can give string values in this. So because it is cars, we'll say Toyota, BMW, Ford, and Honda, right? So these are 4 cars, right? It was not necessary to give all. If I run this, there will be no error right now, and we can just do cout. We can just do cout and cars. Oh, so it brought the. Okay, we'll learn how to show cars and everything right now. But over here, what you now we have. I want to show you. There's just no error. We can give less values, right? We can give less values. The length we have defined over here, number of elements that the array can store. We can in the over here in this array literal, we can specify less values than what we specified over here and add values afterwards. So if I try this now, no error. That means this was correct, right? But if I try to specify more values than specified, like Honda and like Mercedes, right, then you are seeing that REPL itself is giving an underline of that this is not allowed, and we get an error, right? So that was what was expected, right? So quite cool. Okay, so now let's see the same example with integers also. So we can give int nums, and we can say length 3. We can change the length. We can remove this Honda thing, and because we can save integers, we'll just say 1, 2, and 3, right? And this will go perfectly fine, right? So this is very, very cool stuff over here. So now we'll learn how to access the, sorry about if you can hear any background noise, because that's my little sister and she is getting out of hand right now, so that's okay. But right now let's see how we can access the elements of this array over here that we have. So we'll just revert it back to the cars example, right? So over here now, how we can access it, we can just do cout right? And we can say we can specify the array name, and we can specify on what index is what we want to access. So if I want Toyota, it is on index 0. Indexes start from 0, right? So if I want to access BMW, this is the second element, but its index is 1, so I have to give 1 over here. I have to specify 1 that I want. I need to give the index of whatever element I want to access, right? So in these square brackets over here, you have to give the index of whatever element you want to access. So I want to access Toyota, I'll say 0 and it will semicolon. So this will print the first element of our car's array, that is Toyota. Quite cool. So array indexes start with 0, right? The first element is 0, then the second element is 1, and so on, right? So if you want to change an array element, it is quite similar. You can just specify the array's name. You can specify on what index do you want to change the value. So I want to change the value on 0th index, right? And we'll say Audi, right? We'll say Audi. So let's print car 0 before changing it and after changing it. So we'll get Toyota before changing it, and after changing it we'll get Audi. Expected behavior, all of this, right? So first we got Toyota and next we got Audi. So now what we'll do, we'll see how to loop through an array, right? This is an array, how we can loop through it, right? And so let's see it. So over here what you can do, we have defined an array. We can give a normal for loop for int I equals 0, and then we have to say I is less than, and whatever the length is of your array, that is 4. So I less than 4, I plus plus. So this is specifying till your variable I is less than 4. Till then, keep on looping, right? Keep on running the code inside the block, right? And I plus plus is that every time after every execution of your code block, increase I by 1, so that it does not end up in an infinite loop. And in the for loop, cout cars I, and then a new line, right? So let's understand this over here. Let's see, by the value of I. So I will first be 0, right? It will go into this block of code. It will print cars I, so car 0. So it will access the 0th element and print it, that is Toyota, and then it will add a new line. Then it will go back up, it will increment the value of I, it will print the first value, the first indexed value, that is BMW, and then add a new line. Then it will be 2 over here, the I's value will be 2. So it will bring the second index value, that is the third value, that is 4, right? And then its value will be 3, right? So its value will be 3. It will come in here, it will show Honda, and then its value will be incremented to 4. When it will be incremented to 4, it will check I is less than 4. 4 is not less than 4, that's why it will come out of the loop. So in the end, we will have all our cars, all our values in a cars array printed. So Toyota, BMW, Ford, and Honda, as we wanted, right? And what you want to do, if you want to print the index, and then you can, I'll show you. So a neater way of showing this will be, yeah. So over here what is happening, it is printing the index, it is showing a colon, and then it is showing the value of that index. So it will first give 0 equals to Toyota, 1 equals to BMW, 2 equals Ford, and 3 equals Honda. And indexes start from 0, just reminding you once again. 0 equals Toyota, 1 equals BMW, 2 equals Ford, and 3 equals Honda. Very, very cool stuff over here. Now you see over here, notice this array size. You always don't want to limit yourself, right? You don't want to limit yourself to one array size, right? When defining over here, right, you can, if if you want, you don't if you don't want, you cannot specify the array size over here, and at the time of declaration, when the number of elements you give, that will be the array size. So I have not given the array size over here, and I've given a lot of elements. Right now it is because we have not specified the array size, it is counting how many elements I have specified. So it has counted 1, 2, 3 and 4. So there are 4 elements, so it automatically identifies and keeps the array size, the car's array size to 4. Right, it keeps our car's array size as 4. Right, so so for example, over here, this is completely fine, right? However, the problem will come if you want extra space for future elements. Then you will have to override the existing values. So what you will have to do, if you want to give more values, more and more values in the future, then you have to override the existing values. So if I wanted to add Tesla also, I will have to override the whole array. Right, so this I will have to remove and then define it once. So whenever you are declaring the array, right, wherever is the declaration of the array, if you want to increase the size of that array in the future, then you will have to override it and declare it once again. Right, so if you say that you want 6 elements, 5 elements over here, right? So if you want 5 elements over here, just a second. Sorry. Okay. Sorry. If there was an issue right now, just ignore that. I thought that there was an issue occurred right now. Sorry about that. Okay. So okay, let's continue. So over here, when we give the size and don't give enough elements, an extra space is reserved for more elements. So I've given there will be 5 elements and I've only given 4 elements, right? So extra space is reserved for another element, right? So I can then give cars 4 equals to Tesla, right? And I don't have to go back up once again and override the whole array. I can just say that, just add a new element, right? And if I see out cars 4, then it will show us Tesla, right? So there's a plus point about not giving over here the length, and there's a minus point also. So it's your choice. It's up to you how you want to keep it. And one more thing is that what you can do, you can just fully just ignore this and later specify all the elements. So fully just define it, and later in the program you can specify the values of the elements, right? So that is also quite cool, right? And I will not specify them all. It will take a lot of time. Not a lot, but yeah, we don't want to waste time. Quite cool. So this is how you can omit. We saw how you can omit this over here, right? The size of an array. And if you want to know the size of your array, so to get the size of an array, you will have to use the size of method. There's a size of method here, right, that you will need to use. So let's create this in integers array so it's easier to understand. Right. Sorry about that. Or 10. 50, right? And you can just do cout size of, so obviously we should get 5, right? Because the length of the array is 5. So nums, so we should get 5 over here. No, we are getting 20. Why is that happening? Why did the result show 20 instead of 5 when the array contains 5 elements only? It is because the size of operator returns the size of a type in bytes. So we learned in we know, right, that the int type is usually 4 bytes, right? So it takes up to 4 bytes. So from this example over here, if we calculate if you just add all the sizes of the integers, like, so there are 4 bytes per integer over here and there are 5 values, so 4 times 5, 20. So we get 20, right? It adds up all the size, right? Yeah, so it brings the size in bytes. It does not bring the length of the array. It is bringing the size in bytes, how much space the array is really occupying. So to find out how many elements the array really has, we'll just say size of nums, oh I gave that, divided by size of int, right? So we'll just have to do like size of num divided by size of int. So size of int is 4, size of nums is 20, and 20 divided by 4 is 5, and that will be our expected result that will be printed on the screen, right? 5 is printed on the screen and that is the expected result. So now we are starting to come on a very cool concept, right? And that is multi-dimensional arrays. So what are multi-dimensional arrays? A multi-dimensional array is an array of arrays. So using multi-dimensional array, you can have more arrays in arrays, right? So you can have an array, and in that the values in that can be more arrays, right? So quite cool stuff. So to declare a multi-dimensional array, define the variable type. So what type values will be there in your multi-dimensional array? So string, for example, right? Then specify the name of the array letters, right? Followed by the square brackets, which specify how many elements the main array has. So this over here, this square bracket will say how many arrays will be there in our main array, the outer array. So we'll say 2 more arrays will be there in our outer array, and then we give another square bracket saying how many elements will be there in our inner arrays. So we can say 4 letters will be there in our inner arrays, right? So if we give an array literal over here, it will look something like this. Just indented, and A, B, C, D, and E, F, G, and H. So let's see what is happening. This is our outer array, right? This whole thing is an outer array. So in this we are saying that there will be 2 more arrays. So there are 2 more arrays. Now in these 2 arrays, for every array that is in our outer array, we are specifying how many elements will be there in every inner array. So there will be 4 elements, so in both our inner arrays. So we say A, B, C, D, and E, F, G, H, right? So very very cool stuff over here, right? So each set of square brackets is an array declaration. In an array declaration adds another dimension to an array. So now this is getting crazier. You can have as many dimensions as you want in arrays. So for example, I can give 2 and I can say 2 over here also, and I can say 2 over here also. So now look at this, It is quite a lot of difficult stuff to handle, but I'll just show you what is happening. A, B, C, and D. E, F, G, and H. So this is getting crazy over here. What we have our outer array, in which we are saying there will be 2 inner arrays, right? So there are 2 inner arrays. Now we are saying in these 2 inner arrays there will be 2 more arrays. So there are 2 more arrays. Now we are saying in each of the inners array there will be 2 elements. So in each of these arrays there are 2 elements that are strings, right? So you can have as many dimensions as you want, 4, 5, 6, 7, but you will make stuff the number of dimensions you have, the more number of dimensions you have, the more complicated it gets, right? Simple, understand. Okay, so now the main point is over here. I'll just go back to the multi-dimensional or the 3-dimensional, just the multi-dimensional. Okay, so on. So on. Alright, so how can we really access elements from these multi-dimensional arrays, right? The basic question is that. So to access an element of a multi-dimensional array, specify an index number in each of the array's dimension, right? So let's try to do it. So we want to see out, we want to access from letters, that is a multi-dimensional array. So from the outer array, from this outer dimension, we want an element from this, from 0, and in the inner dimension we want the first element. So it will bring first, it will access the 0th array, that is this, and in that it will bring the first element, that is this, first indexed element, right? So B will come over here, it will, oh no, semicolon. So so we are getting B, quite good, but it hasn't ended right now. Things get even more complicated over here. For example, I do 0, 4. What do you expect to happen over here? You're doing A, that is the 0th element, B, that is the first index element, C, that is the second index element, and D, that is the third index element. So this is index 3. There's no index 4. So the obvious answer from your side will be that we will have an error because we are going outside the array. But no, we will access memory, right? We will access data after D, that is there in the memory. So this gets very cool, very complicated, but we will get E over here. Let's see why. Wherever it saved this array, in the immediate after memory location, it saved this array, right? So side to side the arrays are saved. So when it overflows from the array, right, it goes outside the array, it starts accessing memory that is after from what we wanted to access. So we wanted to access this, but it starts looking at things that are after this, right? So that are saved after in the late uh, so so over here you can see this is one memory location, this is the other, though they are side to side. This is from where we wanted to access. If from this we overflow, then it will directly come to this side memory location, right? That is to the side of it, right? So these two arrays are saved together, right? These two arrays are saved together, right? So these two arrays are sticking, we can say they are saved together, right? So over here after A, B, C, D, it will overflow and start accessing memory outside, right? And in the immediate after memory location we have this array, and after this it will try to access one element. Moving forward outside the memory, it will try to access one element, right? One, because we are accessing the fourth element. We don't access the 0th, we don't access the first, we don't access the second, we don't access the third. We will access directly whatever is after this, because this array is now saved right here, right? So it is saved beside, right, in the immediate after memory of this. It will go over here and access E. So this is very cool. It will show us E. And if we wanted to do it the correct way, we would have said 1 0, right? So this is the correct way of accessing E. But yeah, that's also a thing. When we go outside the specified memory from where we want to access, it tries to access data from other memory locations, right? So now if you want to change the elements, it is a very similar thing. How you can do it? You can do letters 0 0 equals to Z. So from A we are changing it to Z, right? Quite cool stuff. And then if we just see out letters 0 0, then it will show us Z. But there is a twist here also. So from the memory location where we were accessing, beyond that we can access values in the other memory locations. But the thing is, beyond the memory location from where we want to access stuff, beyond that we can't change the values. So if I try to do 0 4, that is outside from where we are trying to access an element, that will produce us an error, because we can't change memory beyond, right? So we can't change it beyond. So if I just see out letters, I'll do 0 8 over here. Now I have learned something new myself. You see over here, this is still gonna work, right? It is still gonna work. The thing is, because we ourselves occupied the memory, right? So we ourselves occupied that memory. If we go beyond the memory we occupied ourselves, so like 0 8, that is outside this also, then it will not allow us to do, as that is the memory used by some other programs or by the computer, right? So we are not able to do that, right? And we should have print 08, but it is throwing us an error. Right, so we get an error. Quite cool stuff. Now how can you loop through this multi-dimensional array? You will have to give array in arrays. So for int I is equals to 0, I is less than 2, so till I is less than 2, till then loop over here, and in this also we'll say another for loop in j equals 0, j less than 4, and j plus plus. And in this we'll do cout letters I, j, and then a new line. So let me explain this, and then I'll not explain the three-dimensional one because that is obvious if you know this. So we'll loop 2 times. First time it goes, we'll loop over here. It will complete this loop, right? So this will this code block will get executed 4 times. So it will do letters 0 and then 0 0 0 1 0 2 0 3, right? So it will print letters 0 1, sorry 0 0 0 1 0 2 0 3. Then it will come back over here, it will increment I, and then it will go back and loop 4 times, and it will print letters 1 0 1 1 1 2 and 1 3. Alright, and then the loop will end. So this is how you can loop in through multi-dimensional array through nested loops. So you see, it first accesses letters 0 0 0 1 0 2 0 3, then it accesses 1 0 1 1 1 2 1 3. And now what you can do, you can do the same thing for 3 dimensions. So over here I'll just pull it up, right? So I just pulled that up from somewhere. So over here we have 3-dimensional array that I showed you before also, and over here we have 4 inside 4, sorry 4 inside 4 inside 4. Quite cool, right? And this is how you can loop through 3 dimensions, but I'm not feeling easy looking at this, right? This is just too much of processing power used by of our brain, right? This 3-dimensional array is just using a lot of processing power of our brain. And now, why multi-dimensional arrays? It makes so much things complicated, right? Why should you use a multi-dimensional array? So multi-dimensional arrays are great at representing grids, right? So it is great at representing grids. What you can do, you can create your own small battleship also. Over here I'll show you how to create your own small battleship, and that will be so cool. So the concept of this battleship game will be, computer has not randomly but at specific positions decided where are the ships by, right? So and then you have to guess where are the ships, and when you hit all the ships, then it will tell you in how many chances we guessed, right? In how many chances we sunk all the ships. So first of all, let's just pull up that whole grid for our battleships. So over here we have ships, right? We have boolean values that are 0 and 1s, and we will have 4 inner arrays in our main outer array, and in which there will be 4 elements. So this will be a 4x4 grid over here. So over here on 0 there is no ship. On over here we have placed a ship, over here we have placed a ship, over here we have placed a ship, and over here we have placed a ship. So our aim is to sink all these in as less turns as we can take. The minimum turns that you will take are 4 to sink. If you are lucky enough, you will get every ship in each try. So 4 is the minimum score you can get. So we will initialize a variable hits, how many hits you have done and how many turns we have taken. So while hits, because there are 4 ships, so while hits is less than 4, so till we don't get all the 4 hits, we will initialize int row and column. So we'll set those default values that are 0, so they both will be set to 0. We will say cout selecting the coordinates, right, and we'll say new line. So I'll just zoom this out. I'll make this big afterwards. Okay, so next we'll say cout choose a row number. So we are first making the user choose which row they want to make their head. So choose the row number between 0 and 3. Right, so next we'll say we'll take the input of the row, and whatever input is there we'll save it in row. Same thing we'll do for column. So we'll say choose a column number between 0 and 3 and Cin, and we'll save the value in column. And we are not doing any validating, we are just interpreting the user is giving us the correct values. Next we'll say if ships, and then in which row and column, right? So 1 represents true. So if there really was a ship over here, then it will go inside this if statement over here, and it will say ships row and column is equal to 0, because that has now been hit and there's no more ship left over there. Then we'll increment hits, right? So everything is very logical over here, and we are just going to do cout hit, and then we'll say how many hits are left. 4 minus the hits we have done are left. Nice. And if there wasn't a ship on the coordinates the user gave, we will do cout miss, and we'll say after doing all this number turns plus plus, and when we have hit all the ships and hits is equals to 4, when we come out of the loop we'll say cout victory royale. Ooh. And then we are gonna say cout you won in, and then we say turns, and then we'll say turns. So you won in whatever is the number of turns, and then turns. So you won, like if I went in 5 turns, so it will show you won in 5 turns. So this was a very simple battleship, and let's test out our game. Okay, so selecting, okay, let's make this big. Stop this and run this. Selecting the coordinates, choose row number 0 and 3. 0, choose column number 2. Hit! That was literally, I didn't mean to hit it, right? I really didn't mean to hit it, but luckily I hit a ship. And we are saying hit 3 left, and this isn't looking good. So we'll say hit 3 left. Now that's nice. And I will continue from 0 and 2 only because that was so good. 0 and 2. Hit 3 left. Nice. We'll just go with 2 and 1. Miss. Right? We are getting miss. Nice, 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 nice. Next we'll do 0 and 1. We get a hit. Nice, 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 nice. We'll do like 2 and 1. We get a miss. Okay. 2 and 2. Yes, hit. 1 is left, and that is on 3 and 2. Victory Royale! You won in 6 turns. Very fun, very fun. So guys, your task is to improve this battleship just over here, right? You created your whole battleship through multi-dimensional arrays. Quite sick. You improve this. Comment if you do it on REPL or any other place. Just if there's a URL for it or anything, send it to me. I'll play it, and yep, improve this as much as you can. And thank you guys. I hope you guys liked the video. If you did, please don't forget to smash the like button and share this video with as many people as you can. Thank you guys. Bye. Stay safe, stay healthy, and keep watching my videos. Bye.